This is one of the questions we are going to solve. Alright? Here, we are dealing with atomic and nuclear physics. Okay? Atomic and nuclear physics. And we are dealing with NECO likely examination questions. So this is revision for NECO. Right? Atomic physics has to do with the entire atom, while nuclear physics has to do with only nucleus. Nuclear physics is limited to nucleus. Alright? So, question 1 here is that we are told that the energy levels of the hydrogen atom are given as E subscript n equals minus 13.6 divided by n squared electron volt. Calculate the energy required to ionize the atom from the first excited state. Now, in hydrogen atoms and other atoms too, there are energy levels. What are the energy levels? The energy levels are simply represented by lines. Okay, lines of this nature. Now, the first line is represented by n equals to 1. The second one is n equals to 2. And the third one is n equals to 3. And so on. Alright? Now, in the first line, the energy is 0. This is known as the ground state. The ground state. Then, n equals 2 is the other energy levels are excited states. So, the first excited state is where n is equals to 2. Okay? Which is here. This is where we get and the energy greater than what? The energy greater than 0. E2 is greater than 0. E3 is also greater than what? Than 0. So this is the first excited state. Now the formula for the first excited for the energy levels is n equals minus 13.6 divided by n squared. Okay, that's what we are given here. So if we do our substitution, where n is equal to what? 2, we are going to arrive at E subscript n is equal to minus 13.6 divided by 2 squared. Here our n is 2. This gives us minus 13.6 over 4. And when we divide 13.6 divided by 4. Okay, 13.6 divided by 4. The answer is 3.4 electron volt. So this is E2. This E2 is just from here. Alright? So we now want to know the energy. The energy difference between this level n plus 1 to level n equals 2. That is the energy required, okay, to ionize the atom from the first excited state. So that energy is given as E1 minus E2. E1 is this one, which is 0. Okay, n is equal to 1, so it's 0. That is 0. Then minus, this minus here is this minus. Then open your bracket because there is another minus. So put it inside. Minus 3.4. Okay, then you end up having 3.4 electron volts. Very last question we're going to solve for the nuclear physics. Alright, for nuclear physics. Now, a radioactive isotope has a decay constant of 0.002 per second. Calculate its half-life. Alright, we have to calculate the half-life. So this is a very simple question. Usually this can come in form of objective questions or as a bonus tip or a bonus mark for the theory. Okay? How do we solve this problem? There is a relationship between decay constant. There is a relationship between what? Decay constants and half-life. Alright? So a very simple relationship. Now that we are looking for the half-life, and the decay constant is already given. So we are going to use a simple formula which is lambda. Lambda is the decay constant equals 0.693 over T half. So T half is the half-life. Okay? So this is a constant. This is in 2, okay? Which is 0.693. We transfer decay constant here and bring half-life here. Okay? It therefore means that T half equals 0.693 over decay constant. Alright, since you are giving decay constant, I will define the half-life. So we substitute 0.693 over, substitute for the value for decay constant, which is 0.002. Okay, that gives T half to be equals to, so let's divide 0.693 divided by 0.002. Okay, that gives us 346.5. 346.5 seconds. Please don't forget. Okay, because the decay constant is in seconds. It's in per second, so your half-life will be in seconds. So this is the question. These are all the questions we have. All right. These are the questions. Thank you very much.